In this video, we're going to be introducing system of equations. So before attempting this, let's just make sure you're comfortable with plugging in values into an equation and doing the order of operations. All right, so first of all, what does it mean for something to be a solution? If we say that x equals 2 is a solution to the equation, what does that mean? Well, to be a solution, it basically just means that this equal sign here makes sense. All right, so if I plug in 2 for x, and I just simplify the left-hand side, 2 times 2 is 4. 4 minus 3 is 1. So if I plug in 2, the left-hand side becomes 1. That is equal to the right-hand side 1. So if something's a solution, if it makes the equal sign true. Something would not be a solution, like 3 is not a solution. So if I plug this in, I will get 3 equals 1, and that's not true. So that's why it's not a solution. Anything you plug in that makes the equal sign true is a solution. All right, so what is a system and how is it related to solutions? All right, sometimes in a scenario, there's 2 different things that you need to be true at the same time. All right, one example is when we're factoring. So when we're factoring, we have these like 2 numbers that we're trying to add to be something, and at the same time, they need to multiply to be something. All right, these 2 different things need to be true of those numbers at the same time. All right, so when we have these multiple equations that must be true at the same time, we call that a system of equations. All right, so a system just means you have multiple things that you're trying to work with at the same time. And then what's it going to mean to be a solution to a system? All right, for a single equation, a solution like we saw is when you plug in and that makes the equal sign true. But for a system, you have multiple different equations you're talking about, so you need all of those equations to be true at the same time using the same input. So I can't put in like 2 in for one and 3 in for another. I put just in 2 and it should make everything the same. All right, when working with a system, we'll have multiple variables. All right, most of the time we're just going to have an x and a y, but there's situations where you could have 20 different variables in a system. You don't have to worry about that. All right, so right now we're just kind of introducing systems, figuring out what a solution is. So I'm just going to give you a point and you have to determine if it's a solution to a system. All right, so if this point is a solution, I should plug it in to either equation and it should be true. So let's plug it into the top equation first. All right, x is 2, y is 3. And this equal sign, equal to be 1, should be true. So if I simplify the left-hand side, 4 minus 3 is 1. All right, and that equal sign is true. So 2/3, or 2 comma 3 is a solution to the first equation, but we also have to check the second equation. So we plug in 2 for x and 3 for y. You want to see if this equal sign is true. 3 times 2 is 6, and 9 equals 9, and that's true. So is 2/3 a solution? Well, if I plug into both of these, they're both true, so it is a solution. All right, what about 2 negative 1? Is that a solution to this system? Well, we know what we have to do. We need to figure out, does this point solve both of these equations at the same time? So we try the first one, 3 times 2 plus 2 times negative 1. And we want that to be 4. This is 6 minus 2, and that is 4. So we get an equal sign that's true at the end, so this does work. That is a solution. And let's try the other one. 2 minus 3 times negative 1. We want that to be 6. This is 2 plus 3, but that's 5, and 5 is not the same as 6, so this one doesn't work. And this is where it's important when you recognize that it's a system. It's good that it worked in the first one, but it didn't work in the second one, so this is not a solution because it only worked in one equation, not both. All right, so here's the one for you to try on your own. I determine if this point is a solution to this system. I'll show you the answer in 3, 2, 1. And the answer is yes, it is a system. When I plug it in both these, they're both true, so it is a solution. All right, so here's a quick summary of the important things. All right, a solution to a system solves all equations at the same time, so just solving one's not good enough. And for right now, just to verify if something's a solution, just plug it in, make sure that equal sign actually makes sense.